Merdita. Well, that's the way we say hello in Albania. Hello, children. How are you people doing? I'm Saurabh and I'm here to teach you people a little bit of mathematics. Now, children, at this moment we are doing combinations. This is when you're given n objects, and out of that you pick up, say, some r objects, and you want to find out a combination or a selection. Now remember, whenever we require a combination, then the order becomes unimportant, right? So before we do sums with combination, we should first be knowing what is the notation of combination. So at this moment we'll be discussing what the notation of the combination is when we have n objects in total, out of which at a time r are to be chosen to form the combination, right? So here the notation for this is, we talk about n, which are the number of objects that we have at hand, and when we've got to choose, say, some r out of which the combination is to be formed, we call it to be NCR. I'm sure if you studied binomial theorem, there also you find this notation. So if we talk about this NCR, it is written like factorial n divided by n minus r factorial times of r factorial, right? So this, children, is the notation of combination. Now next we will be quickly discussing what you mean by factorial of a number. For that matter, let's say we have factorial 7 and we're going to find this out. So next, now we will write this to be the largest number that we see here, and then we multiply this with one lesser a number from the set of natural numbers, that is 7 into 6. Further again we will subtract 1, and that will become into 5 into 4 into 3 into 2 into 1, right? So this is the factorial of a number. Remember, if somehow you get factorial of 0, then factorial of 0 is equal to 1. For that matter, if you're doing something wrong, then you will get the factorial of a negative number, let's say minus 4. And always remember that its value is equal to 0. So there were a few things that I discussed just now, which I like to quickly discuss. Now when we talk about this topic combination, it is when out of n entities we want to select r entities with which we form a combination. In a combination, which can also be said to be a selection, the order is not important. Now if we require to find out the combination every time, we don't think about a strategy, we have a fixed strategy. For that matter, we talk about a notation, right, which represents the number of combination which are possible. So if we talk about the notation, it is NCR, right? Now here NCR can be found out by writing the factorial of the number which is in the superfix, a natural number, and then in the denominator we have the factorial of the difference of both of these natural numbers which are in the superfix and in the suffix, and then in the denominator we also have the factorial of the number which is there in the the suffix, right? Now whenever you have factorial of a number, that is written something like this. We write the largest number, that is whose factorial we are finding out, to be multiplied with the next natural number which is just lesser to it, then to be multiplied with a natural number which is just lesser than it, and so on we continue up to the first natural number which is 1. This is how we get the factorial of a number. Now sometimes it is possible that you can get factorial of 0, so that is no problem. Remember, factorial of 0 is equal to 1. If in writing this notation you're doing something wrong, that is, if you've kept the value of n to be lesser than the value of r, then you will get the factorial of a negative number which is an integer. That means minus multiplied with a natural number. In that case, remember, something like factorial of minus 4 will become equal to 0, and that is where it will indicate you that you made a mistake, because then you will get a 0 in the denominator, which will make the denominator in whole to become 0. As such, it will become an undefined number. Okay, so now, children, we've understood what the combination notation is. Now we'll be discussing some sums with it. So let's get started. So at the moment, I'd like you people to pause the lecture, write all of this down, learn this up, right, and then write this once more in practice, and after that come over to the sum. Now, children, the first sum that I have for you people is something like this. right? I expect by now you must have paused once, written all the notes. Now after you see this question, you will pause the lecture once more, you will try it out. After you've tried out, then you will play the lecture again and then look up the solution, pause the lecture again, and then try it out once more. This is how the learning will become wholesome. You will understand things, and the understanding is going to stay with you for a long period of time, right? So now children, we come over to this sum. We have find n if nc1, nc2, nc3, these are three combination notations which are in AP, right? So at this time, first I will give you 10 seconds for trial. After these 10 seconds, then I'll be taking out some time and I'll be discussing the sum with you people. Okay children, now let's discuss the sum. In the question we've been given, you've got to find out the value of n when these three numbers are in AP. So reminding you people first that if you have three numbers, something like say A, B, C, which are in AP, then remember the second term, that is B, right, is equal to 1 upon 2 times the sum of A and C. Or in other words, we can say that the common difference is equal. As such, we have B minus A to be equal to C minus B, and this is how we get what I told you first, that is, if you bring over minus B to the left hand side, that is, if you transpose it to the left hand side, we will get 2 times of B, which will become equal to A plus C, and as such you will get the value of B to be equal to half times the sum of the first term and the third term, right? So this is what you get from three terms which are in AP, right? And this term, which is B, is also said to be the arithmetic mean. So an expression for the arithmetic mean, when three numbers are in AP, the middle term is given by A plus C upon 2. These are different facts which can be used in different questions, especially objective type questions. At this time now, we have NC1, NC2 and NC3 to be three combination notations which are in AP. As such, using this concept that you just learned, we can now say that we have NC1, NC2 and NC3 to be in AP. So if these three are in AP, children, next what we can do is we can now write this to be NC2 minus NC1, which will become equal to NC3 minus NC2. Right now here, if we try and solve this, we can now write this as n factorial divided by n minus 2 factorial times of factorial 2 minus n factorial divided by n minus 1 factorial times of factorial of 1, which will become equal to n factorial divided by n minus 3 factorial times of factorial 3 minus we have n factorial divided by n minus 2 factorial times of factorial of 2. Right, so next now children, what we can do is here we can write this as taking over the second binomial coefficient, which we find to be common in both the sides, to just one side. So we have n factorial divided by n minus 2 factorial times of factorial 2 coming twice. As such, we pick both of these up and put them in a single side. So now we transpose the one which is a negative, that is the second notation coefficient, to the left hand side. So now we have 2 times of factorial n, right, divided by n minus 2 factorial times of factorial 2, right, which will become equal to factorial n divided by n minus 3 factorial times of factorial 3, and to which is going to be added factorial n divided by n minus 1 factorial times of factorial 1. Right, next now children, what we do is we will further solve this like we looked up, that if we have some NCR, we write it to be n factorial divided by n minus r factorial times of factorial r. So writing this now, we have 2 times of factorial n, which is going to be divided by factorial of n minus 2, which we will simplify in the next step. Now this is factorial 2, which will further become equal to again factorial n, which can now be taken common outside, and inside then we will have 1 upon factorial of n minus 3, right, times of factorial 3, to which is to be added 1, because factorial n has already been taken out, divided by factorial of n minus 1 times of factorial 1, right. Now children, we get to see that we have factorial 1 factorial n on either side, so we can cancel it off, right. So we have done some simplification. Further, we are to simplify further. Now we get to see that if you talk about factorial of a number, right, such that if you're subtracting a larger number from a number, then the number will become less. For that matter, we will quickly have an example here. Like suppose if we talk about 4, right, and let us subtract from 4 2, and let us subtract from 4 1. I'm sure you know this, that if we talk about 2 is larger than 1. So when a larger number is subtracted from a number, than in the other case when we subtract a lesser number from the same number, then the earlier number is going to become lesser, right, and the later number will become larger. As such, now we can say that we will now have 4 minus 2, which is 2, to be becoming lesser than 4 minus 1. So what have I said just now? That if from a number you subtract a larger number, then the number will become less in comparison to when you're subtracting a lesser number from that number. Similarly, children, here if we talk about now, say n minus 3, n minus 2, and n minus 1, we get to see that 3 here is the largest, 2 is lesser, and 1 is the least. So when we subtract a larger number, so we expect to get the number to be lesser, and further the number to be lesser. Or in other words, if we talk about the number which is n minus 3, it's the least. The number which is n minus 2 is greater, and the number which is n minus 1 is the largest, right? So we will use this fact now as to tell this now that we have now factorial of n minus 2, factorial of n minus 3, and factorial of n minus 1. Among these three, factorial of n minus 1 is the largest, right? So now we can write this as n minus 2, right, factorial, right, as something like this, that if we talk about factorial of n minus 1, as we find that this is the largest, so we can write this as n minus 1 times of n minus 2 times of factorial of n minus 3. Similarly, if we talk about factorial of n minus 2, then we can write it as n minus 2 times of factorial of n minus 3. And if we talk about factorial of n minus 3, we will keep it to be as it is, that is factorial of n minus 3. As such, the common factors, when they'll get cancelled. Now n minus 2 is going to be multiplied with factorial of n minus 3, right? And as factorial 2 is just 2 into 1, so as such what will happen is 2 in the numerator and in the denominator can very easily get cancelled. We will do the cancellation later. Next, now we have the sum of these two fractions. Like I told you, let us leave factorial of n minus 3 as it is. Then we have further here factorial of 3, which can be written as 3 into 2 into 1. To it now is added 1 upon factorial of n minus 1, which can be written like n minus 1 times of n minus 2 times of factorial of n minus 3, right? And with that is multiplied 1, which is a multiplicative identity. Now we will solve the right hand side further. So the right hand side can be seen as 1 upon factorial of n minus 3, which can be taken common out, and then inside we are left out with 1 upon 3 into 2. And if you talk about the second term, we are left out with 1 upon n minus 1 times of n minus 2, as factorial of n minus 3 has already been taken outside, right? Now on the left hand side, children, what do we have? We have 2 divided by n minus 2 times of factorial n minus 3 times of 2. So there are a few things which can be cancelled off now. That is, 2 will get cancelled from 2 in the denominator, right? And then you will also see that factorial of n minus 3 will get cancelled from the left hand side and the right hand side. So now we are left out with simple entities. That is, now you'll be left out with 1 upon n minus 2, which will become equal to here. In the LCM, you will have 3 into 2, which will become equal to 6, which is further multiplied with n minus 1 times of n minus 2, right? And here thus you will have n minus 1 times of n minus 2, from which 6 is to which 6 is to be added, right? So that was because if we talk about the denominators here, now the denominators had 3 into 2 and the other denominator had n minus 1 times of n minus 2. So the LCM will be the product of all of these different numbers, that is 3 into 2 into n minus 1 times of n minus 2. Now next, you will have n minus 1 times of n minus 2, which will be multiplied with 1 to become the numerator of the first fraction, and then you will have 3 into 2, that is 6, to be becoming the numerator of the other fraction. Now next, what we do is we will solve this out. So in order to solve this out, children, we get to see here that again n minus 2 can be cancelled off from both the sides as it is in multiplication. Now on the left hand side, we are just left out with 1, and in the right hand side, now further we can write this as n square, right, minus 2n minus n plus 2 plus 6, right, and that is divided by 6 times of n minus 1. Now we cross multiply, so we will now get 6 times of n minus 1 transposed to the left hand side, and the right hand side becomes n square minus 3n plus 8, right? So for the children, we now multiply this within, so we now get 6n minus 6 here, and on the right hand side we have n square minus 3n plus 8. So further on solving this, we will get n square minus 3n minus 6n will become equal to minus 9n, and 8 plus 6 will become equal to 14, will become equal to 0, right? So for the next, now what we do is we now have to factorize, so we will write the product of the prime factors of the coefficient of the quadratic term and the constant term. So that comes to 2 into 7, that is 14. From this, now getting to 9 is pretty simple. We can now write this to be n square minus 7n, right, minus 2n plus 14 will become equal to 0, remember, is equal to 0. Now here, children, remember that here as we have 2 minuses and 2 pluses, as such factorizing this will become perfectly possible. Out of the first two, we can take n to be common outside, then when we write n minus 7 here, right, then this is perfectly fine as we get the two terms which we required. Now when we write n minus 7, this will go minus 2 times to give us minus 2n plus 14, right? Now out of these two terms, we have n minus 7 which can be taken common outside, then we have n minus 2 inside, and their product becomes equal to 0, right? Now children, here when we talk about the values of n, we will get the value of n either to be equal to 7 or it will come to 2, right, by the zero product rule. Now children, let's quickly look up whether the value 7 is possible or not. So if here we talk about keeping the value of n to be equal to 7, then we get the three terms to be 7c1, 7c2 and 7c3, which are in AP, which is perfectly possible. However, at the other time, if we talk about the value of n to be equal to 2, let's quickly check whether that's possible or not. So when we talk about keeping the value of n to be 2, we will have 2c1, 2c2, which is perfectly possible. But if we talk about 2c3, that is not going to be possible because the value of n cannot be lesser than the value of r, right? So as such, the value which can be accepted can only be 7, and thus you can say that the value 2 is not possible, and thus you can say that the answer comes to be n to be equal to 7 is that we had to find out. Now children, all of this I will just quickly discuss once more. In the question you've been given here that you have here to find out the value of n if nc1, nc2, nc3 are in AP, right? If you have three numbers in arithmetic progression or AP, you can say that the common difference is going to be equal, or in other words, b minus a is equal to c minus b, right? So further now, if you talk about b plus b by transposing minus b to the left hand side, you will get 2b to be equal to a plus c, or in other words, b will become equal to a plus c upon 2. So this is the concept that we are going to apply when we have these three combination coefficients which are in AP. So we have NC1, NC2 and NC3 which are in AP. As such, we can say that NC2 minus NC1 will become equal to NC3 minus NC2. By applying that common differences are equal, you can write that in bracket so that the teacher is able to understand that you have used this concept. Common differences are equal, right? Remember to apply formulae, write them, right? Don't just apply formulae and don't write the formulae. Make sure you write the formulae, and that too in a different colored ink. Put that in a box so the teacher can understand. So the box can be, say, something like this, like you applied this formula here, that is the common differences are equal. Put that in a box, preferably in blue or in black color, which are the two colors that you can use. So if you're writing in black ink, then put this formula that you used in a blue box, right? Okay, now children, we come over further to the concept that we've used. So now we are going to keep here the values of these combination coefficients. That is, the value of NC2 will be written as factorial n divided by n minus 2 factorial times of 2 factorial. NC1 is going to be written as factorial n divided by n minus 1 factorial, and 1 factorial will be written like 1 factorial, right? So this is how we will write these combination coefficients. For that matter, NC3 will be written as factorial n divided by n minus 3 factorial, factorial 3, right? NC2 has already been told to you how to write it. Then further, what you can do is you can write this binomial coefficient or this combination coefficient, which has come twice, taken over to the left hand side. So we will have 2 times of factorial n divided by factorial of n minus 2 times of factorial 2 to be equal to the sum of NC3 plus NC1. Now children, here we find that we have factorial n, which can be taken common from the right hand side. So as such, we will take it common outside, right, and cancel it off. Now we come to solving these factorials. Factorial 2 or factorial 3 or factorial 1 is pretty simple to write. So we've just written them as 2 into 1, 3 into 2 into 1, or just 1. When now we come to factorial of n minus 1, n minus 3 and n minus 2, we find that factorial of n minus 1 will be the largest, factorial of n minus 2 will be lesser, and factorial of n minus 3 is going to be the least. How do we understand this? I made you understand this with an example, that if suppose we talk about 4 to be a number, and from that a number which is larger like 2 than 1 is subtracted. So when a larger number is subtracted from a number, then the number becomes less. Similarly, if we talk about here n to be a number, right, and if from that we subtract the largest number, that is 3, we will get this to be the least. Then if we subtract a lesser number, it will further become less. If we subtract just a less number than 3, that is 2, then this number will then become next less. But if we subtract the least number like 1, then this number is going to become the largest, right? So what have I told you? That if from a number we subtract a larger number, then the number will become less. So 4 minus 2 will become lesser than 4 minus 1. Similarly, when from n we are subtracting 3, which is the largest, or 2, which is a little less large, and 1, which is the least, n minus 3 becomes the least, n minus 2 will become the next larger, and n minus 1 will become the largest. As such, factorial of n minus 1 will be the largest, factorial of n minus 2 will become next larger, and factorial of n minus 3 will become the least. As such, if we write the factorial of these numbers, it's best to write in the form of factorial of n minus 3, which will be there in these 3 factorials. So factorial of n minus 3 is going to be written as factorial of n minus 3. However, factorial of n minus 2 can be written as n minus 2 times of factorial of n minus 3, and factorial of n minus 1 can be written as n minus 1 times of n minus 2 times of factorial of n minus 3. right? So now children, we have written all of these factorials in this format, right? That is factorial of n minus 2 as n minus 2 times of factorial of n minus 3. Factorial of n minus 3 will remain to be as it is, and then when we talk about factorial of n minus 1, it will become n minus 1 times of n minus 2 times of factorial of n minus 3. Now children, we find that in the two terms of the right hand side, we have 1 upon of factorial of n minus 3, which is common, and inside we'll be left out with 1 upon 3 into 2, and in the second term we'll be left out with 1 upon n minus 1 times of n minus 2. As 1 is multiplicative identity, so it will vanish into thin air. Now factorial of n minus 3 will get cancelled from both the sides, so now you have 2 divided by 2, which will get cancelled from the numerator and the denominator, times of factorial of n minus 3. Now factorial of n minus 3 getting cancelled, you will just be left out with 1 upon n minus 2, right? Next is the task to take an LCM of the fractions which are left. So here we have these three numbers, 3, 2, right, and the product of n minus 1 times of n minus 2. We will write the product of all of these different numbers as the LCM. Now we find that as all of these numbers are in product on either side of the equation, from the denominator n minus 2 being common with n minus 2 will get cancelled. As such, we'll be left out with n minus 1 times of n minus 2 plus 6 divided by 6 times of n minus 1 to be equal to just 1. So here further we will cross multiply the 6 times of n minus 1 to the left hand side, and then we will get 6 times of n minus 1 to be becoming equal to n square, right, minus 2n minus n plus 2, right, plus 6. So for the children, what will happen is we will get this to be minus 3n, right, and 6 plus 2 will become equal to 8. Now we will transpose after multiplication of 6 with n minus 1 to the right hand side. So we will get n square minus 3n plus 8 minus 6n and plus 6, right? So further here we have n square minus 9n, right, and plus 14, which becomes equal to 0. Now we write the product of the prime factors of the coefficient of the quadratic term and the constant term, which is just 2 into 7. Now from 2 into 7 we can bring 9 as minus 2n minus 7n. That is how we write the middle term broken up in terms of product of prime factors, sum or difference, right? Now as we have 2 pluses and 2 minuses, so obviously this will get easily factorized. So out of the first two, we take n to be common outside. Inside we are left out with n minus 7, right? And now when we write n minus 7, this goes minus 2 times, so that we get the next two terms. So now out of these two terms, we can take n minus 7 to be common outside. Inside we are left out with n minus 2, right? Their product becomes equal to 0. Now we apply the zero product rule, which once when taken n minus 7 to be equal to 0, we'll get the value of n to be equal to 7, and at the other time when we write n minus 2 to be equal to 0, we will get the value of n to be equal to 2. Now is the time when we check whether both of these values are correct or not. So we put it in the primary condition that we've been given, that is NC1, NC2 and NC3 are in AP. So if we keep the value of n to be 7, we have 7C1, 7C2 and 7C3 which are in AP, which is perfectly fine. But if we keep the value of n to be 2, we have 2C1 which is perfectly fine, 2C2 which is perfectly fine. But when we talk about 2C3, this will not be fine, as the value of n is becoming lesser than the value of r, right? And then we will get like what we discussed just now, that is we will get the factorial of a negative number, which will become 0, and getting a 0 in the denominator will give you an undefined number, and that is why 2 will not be accepted as a correct answer, and thus the final answer is that the value of n should be equal to 7, so that this condition with the combination coefficients be correct. So is this lecture on combination notation perfectly clear with you people? Shreyas? Sure? Any doubt, do let me know. And how you found this lecture, do write me in comments, and in comments also tell me which is the next chapter that you like me to discuss, so that I can put up the lectures of that, so that in times to come, when it comes in an examination, you are going to do that very well, and you'll be faring very well in your examinations. Bye now, and have a nice time. Do practice all of these sums. Bye.